over to you, Innes.
Awesome. Thanks very much, Andrew. Good morning, everybody. It's great to be here and I guess helping to reduce our carbon footprint by doing something online, making it a little more accessible. I think this is going to be recorded, and it probably will be available later for anyone who might have missed out joining us on the live webinar. Okay, so the purpose of the webinar today is really to talk about AS5488. Which is, it's a key part of, I guess, the locating industry in Australia, and it's really something that we wanted to talk about today because not a lot of, I guess, industry stakeholders in the asset side or the locators are really very familiar with this. So Andrew's already given me a bit of an introduction, so I'll skip that. Too much, but just to say that I am a professional locator. I'm one of 2 Australian beforeUdig certified locators here in New Zealand. And as Andrew said, I've been on the NULCA Australia committee. I spent 3 years on the committee as a committee member. Just a little bit about NULCA New Zealand. Really, we set up NULCA New Zealand to represent the New Zealand locating industry and those people who are involved in locating and protecting New Zealand underground services and infrastructure. So NULCA New Zealand's mission is really about building an industry and setting, I guess, New Zealand up as a bit of a leader in the locating space by introducing best practices and really learning from the experience of both NULCA United States and NULCA Australia, who are kind of sister organisations. Through the presentation, you'll see at the bottom of the slide in the footer the web address for the NULCA New Zealand website, and I encourage you to go take a look. It's still a work in progress, but we're getting there. So let's talk about what is AS5488. So AS5488 is the Australian standard for classification of subsurface utility information. Really, it's a framework for recording, depicting, and communicating information about existing underground services. It's not a particularly new concept. The United States had a standard there, or it still has a standard, AS5488. I guess what you could say is one of the forerunners for this type of standard for information around existing underground infrastructure. But following on from the US, AS5488, Canada, Australia, the UK, which introduced PAS 128, probably only a couple of years ago, as another, and of course Australia in 2013 introduced the first AS5488 version. But there are a few other countries, Ecuador, Malaysia, all have similar frameworks around SUI. So AS5488 was originally published in 2013, and that was the first version. There was a lot of stakeholders involved in Australia. One of the key players there was NULCA Australia. They were heavily involved. Ian Lambert is the president, current president as well of NULCA Australia, was heavily involved in that. But they drew from a wide sector of stakeholders, asset owners, regulators, and the locating industry as well, and also including the DBYD, beforeUdig's equivalent in Australia. It's had a recent update, not a huge change. They've introduced a second part to the document, which is supposedly there to more provide information for the civil engineers on how best to use the standard. So it's more an informative part of the standard as opposed to any new particular requirements. So part 1 of the version republished this year is really still very much the same as the 2013 version, but they've obviously tweaked a few changes in there just to address some issues around clarity, around the quality levels. So AS5488, or in fact any subsurface utility information framework, really has, I guess, a number of key audiences. Obviously the asset owners, operators and regulators. So that's the likes of the electrical distribution network owners, gas distribution network owners. Then obviously the locators, who are heavily involved in locating the services that are already on the ground. But I guess one of the other key stakeholders is the civil engineers as well, both for how they represent information for things like project designs, tenders, contracts, and I think the update for the standard in 2019 was to help that particular sector, the civil engineers, to better understand and make better use of AS5488. Okay, so the standard in a New Zealand context. New Zealand currently has no equivalent subsurface utility information framework. New Zealand did get the opportunity to participate in the original development of AS5488, and I suppose, like a lot of other standards, it could have been a cross-Tasman Australia-New Zealand standard. However, for whatever reasons, there's a bit of history there, that opportunity wasn't taken up. So Australia went ahead and developed AS5488 as a standalone service, and we never really picked up that option here in New Zealand to take it up. There have been a few documents over the last 4 or 5 years which have come out to try and set a similar sort of framework, but more aligned with best practice. One of them came out of SCIRT, which was the organisation following the Canterbury earthquake, that was set up to do all the, I guess, the redevelopment and the recovery. And NZTA also published a best practice document, which had similar structure, if you like, around quality levels, which is a core part of AS5488. There is a 2002 document, the OSH, Department of Labour then it was, Occupational Safety and Health Guide for Safety with Underground Services. That's really the only document that I know of anyway, that covers things like symbols used for underground services and the designation of particular colours that should be used for marking out or for duct colours. So we really lack any kind of formal or structured framework for specifying how you depict underground services and plans, how locators might communicate the level of confidence they have around a locate that's done for a particular service. And the reason, I guess, you probably say, well, okay, well, so what? We don't have anything, but why would we really be interested in AS5488 at this time? A lot of this is being driven really by the introduction of the beforeUdig Certified Locator program. In Australia, as a beforeUdig Certified Locator, you are required to know AS5488. In fact, I think one of the requirements for the practical test, or at least one of the requirements, is that you have available a copy of AS5488, or at least have access to it. So that standard in Australia, although it's taken a long time for it to become well known, is actually quite significant, and it's increasing in its use. And really, to introduce a certified locator program in New Zealand without having something available of a similar, I guess, type here, was something that we decided wasn't really going to work. And the other aspect of bringing it in as part of the certification is that if we ever get to the stage of having reciprocal recognition of our certifications, our locator certification, then you'll probably be, as a New Zealand certified locator, required to be able to demonstrate the knowledge of AS5488. And that's aside from the fact that it's actually not a bad thing to have as a best practice. So what are the key elements of AS5488? It's not a very big standard. I think it's might run to about 20 odd pages. A substantial amount of that are the appendices at the back. But key aspects of the standard are the definition of what they call quality levels. And there are 4 quality levels that are defined in the standard. And they range in, I guess, a level of confidence from lowest to highest. And D, a quality level D, is defined as basically the lowest level of confidence in the location or the position of a particular asset. And each quality level really reflects the precision of accuracy of the utility's location and the level of information that's actually known about the utility. It sounds like a big fancy word, but they call it metadata. It's really information about the particular asset that's in the ground. Each level from D to A requires an increasing amount of detail around the asset. And the standard also states how the asset position can or must be measured. So you can imagine that to get the highest level of confidence around the position of a particular asset, you're really looking at something like accurate surveying of the asset's location. And each level basically stipulates what the requirements are around the way it's measured or how its positioning is relative to, I guess, other aspects, whether it's a physical aspect or a geospatial aspect. And the other key part about each level is they assign what they call a tolerance level. So this is really a tolerance around the margin of error that can be tolerated, if you like, for the position of a particular asset. And we'll have a look at those as we go through each of the quality levels. So the thing to remember is that a quality level D is the lowest and has the least confidence, and a quality level A has the highest confidence. It's also what they call a validated locate, and we'll see why as we look at each of the individual quality levels. So quality level D, as I've said, is really the lowest level of confidence, and that level of confidence is basically assigned whenever you're using anything like a plan. So any plan, however detailed or how accurately it might have originally been measured, is considered to be a quality level D. So as a locator, basically a starting point would be a quality level D if you had to mark out based on a plan that's been provided by the asset owner. And as you'll see in the slide, you'll get varying degrees of quality of information around plans. Some have reasonable offset measurements, say from relative positions off curb lines, off fences, off identifiable above ground infrastructure. The thing is that you don't actually know whether those above ground objects are still the original ones that the measurements were taken off, whether they've been moved. So really, a plan is an indication of an underground service in a particular position, and there's almost no reliance on it as a way of locating unless that's your only option. One of the things I'm seeing more and more, particularly from the civil engineers that are preparing project documents, is what I call a beforeUdig overlay. And essentially they're taking all the plans available from beforeUdig and possibly other sources like council GISs, and they simply dump them onto a single plan, And unfortunately, some people seem to take those as being, you know, in some way accurate, which they shouldn't. And those plans should really be treated with a great degree of skepticism, particularly as a locator or any kind of project or contract management aspect. With quality level D, really it's based on existing records. You might have gone out to site, had a quick look around, or if you say on a private site, Fred, the site engineer, might have come and says, oh look, there's an 11 kV cable here. I think it runs more or less down here somewhere. And so that's the kind of information you're talking about as a quality level D. There is no measurement tolerance because there's nothing to measure, essentially. So there's no margin of error associated with quality level D. And it has the least amount of information. So you might know who the owner is, and you also might know what type of service it is, but that's about it. The next level really is a step up, is what we call a quality level C, and that's where what we say is correlating some above ground infrastructure. So the best example of this would be if you have two manholes for a sanitary sewer. You lift the manholes and you see a pipe goes out of one and it comes into the other one, which is just down the road. Now, for whatever reason, you may not be able to do a proper locate on the pipe that goes between the two manholes. So essentially you survey the two manholes and you assume that there's a straight line that goes from one manhole to the next. And that's really the basis of a quality level C locate. The other classic example would be, say, two water valves on a water main. So you've got one in the footpath and you've got another one just a bit further down on the corner of the road. And you know from the plans that you've received from the asset owner that in theory the pipe goes from one valve to the next in a straight line. So without actually locating the pipe between the two above ground assets, you make an assumption that this is how it goes. Now, as any locator will tell you, that's not always the case. Sometimes the services are laid slightly differently. And GIS often draw straight lines, whereas the original pipe might have been laid with, for whatever reason, a bend or curve, or it might have stepped around a particular object in the ground. So the quality level C always builds on quality level D. So you really need plans to support what you see on the surface. Now, this is the first quality level that introduces a tolerance. And so what we're talking about is plus or minus 300 millimeters either side. So if you drew a straight line between two manholes and you marked up, then in theory the asset is within plus or minus 300 relative positioning. And relative positioning is another aspect of the standard which you need to get your head around. It's a measurement based on other objects, so that accuracy is relative to other objects as opposed to a surveyed position, which is what they call an absolute position. So you can see in the diagram you've got a couple of surface features. You might have another one in the middle, which is maybe a fire hydrant off a water main, and essentially you've assumed the position of the asset between those above ground features. So for a locator, the quality level B is probably the one we come across most often. This is subsurface location based on tracing, and I'll talk very briefly in a minute about what tracing means, because that has changed from the original 2013 AS5488 standard to the 2019 version. So there's a bit of a difference in there, which kind of clarified a bit of a grey area. Essentially, a quality level B locate is in 3 dimensions. So now you're talking not only a horizontal position relative to the surface of the ground, but you're also starting to talk about depth as well. So your measurement from ground level or grade level. It's also where they put what they call undefined assets. Now, as any locator will know, sometimes you get to site, particularly private sites, where you come up with unknown services. So you know there's something there that's perhaps conductive, or you've been able to at least get a signal off something that can't be assigned to any other particular asset. That becomes an undefined asset, where you don't know who the owner is, you don't know what the particular type is. And this is a new thing that was introduced in the latest version of AS5488. Again, the tolerance for quality level B is now plus or minus 300 in the horizontal. And again, that's relative positioning. But now I've also introduced a vertical tolerance as well, which is plus or minus 500. So technically speaking, when you're giving a depth for a subsurface feature, like a pipe or a cable, if you're working on a vertical depth, then you need to assume that there's a margin of error which can be up to ½ a metre. Now, it sounds an awful lot, and I can kind of see why they might have picked to go 500 millimetres either side vertically. But a lot of locators put out very precise measurements when they're making out depths. Now, with a quality level B, this introduces a margin of error. So anyone that's working on, I guess, as-built designs that are trying to avoid conflicts between services, they need to bear in mind that a quality level B stipulates that there is a margin of error, and it can be up to ½ a metre. So you can see in the diagram there that basically you've got surface features, and it comes back to the way they've redefined tracing. I've actually put a little excerpt from the current version of the standard in there, which says to trace is physically locate a known service by applying an electromagnetic signal along or within the utility to a known point or a visible point, not limited to the area of interest. Now, this is something new that was introduced in the 2019 version. The original version from 2013 only said that you had to trace it electromagnetically. It didn't allow for really validating the fact that you can follow the signal from, say, a low voltage electrical pillar to the house, or vice versa, to prove that well, not prove, to demonstrate that it's most likely to be an electrical service. And this is something that they've introduced in the latest version. So you'll also see that they now talk about applying a signal along, which would be your normal EM location induction for locators, or within, which would include ducts or pipes that you put either a tracer rod or a sonde into. Which brings us to the last quality level, which is quality level A. So as I said before, this is the highest confidence level, and it's what they call positive identification or validation. So essentially, you have to cite the actual service, and it has to be measured with absolute spatial accuracy. So essentially, you're talking about surveying it, and you'll see that the tolerance, the measurement tolerance now is plus or minus 50 millimeters, which is a very small margin of error. But if you physically sighted it, you can see the asset, and if you'd surveyed it accurately to survey grade, then you're pretty much going to be able to achieve that plus or minus 50 millimeters. But that's essentially the measurement. So if you're using mapping grade surveying, which only gives you maybe plus or minus 400 or 500 accuracy, then you can't achieve a quality level A by surveying that surface, even if you can physically see it. So that's the difference. The other thing is that quality level A is about a single point, and you can get a quality level A along a complete cable if it was surveyed at the time that it was laid in the ground. But often with locating now, you locate it with a quality level B. So you find the asset, physically locate it with EM location, and then you pothole with a hydrovac or some hand digging. Basically, that one point is the quality level A. You can't apply quality level A beyond that point because you can't see the surface, you can't measure the surface. So you have to be very careful about how you treat a quality level A. I have seen cases where an asset's been potholed either side, visualized, and it's assumed that it's gone straight between the two quality level A points, when in fact that wasn't the case. It did something quite odd in between those. So it's very dangerous to assume that with a couple of quality level A points, you can extend it across the whole service. So I guess we're getting pretty close to time now, and I really wanted to talk about AS5488 and certification, because I know there's probably going to be a few locators who have joined us this morning to try and understand what AS5488 means in terms of doing the beforeUdig certification that's coming. And hopefully announced today, Andrew. I'm fingers crossed. There's a lot of work to try and get it across the line today, and I'm hoping that happens. But AS5488, so knowing AS5488 will be part of the required knowledge for the beforeUdig Certified Locator program. So if you're going to go through to do that certification, then you will have to know, have some at least basic knowledge of AS5488. It is a good habit to start to use that AS5488 quality levels in your communication with clients. So that locator client communication, it's a good idea since we have nothing else at this particular time. Also, having AS5488 as part of our certification is probably going to be important for our future recognition between Australia and New Zealand of our certified locator programs. So we thought we'd introduce it now as opposed to try and bring it in later, just to make it part of our current certification. So if you're going in to do your certification, you really need to know the quality levels, what they mean and how each of them is derived. And you also need to understand about the measurement and tolerance. You don't need to understand all the metadata information and all the other stuff. If you get a copy of the current AS5488 standard, you'll see that there's an appendix at the back that has a whole lot of colours and naming conventions. Those are guidelines for Australia only. And the service colours and designations in New Zealand, we have no standard. The only, I guess, consistent guideline, and this will be part of the beforeUdig Certified Locator testing, is to understand what's set out in the OSH 2002 guidelines for the service naming convention and the colours. So it's kind of an extra bit in there. Not only do you need to understand AS5488 quality levels, but you also need to take a look at that OSH guidelines as well, particularly around the colours and the naming conventions. You don't need to buy a copy of AS5488 unless you absolutely have to. You'll be able to get that from Standards Australia. So more useful information. This is all very new, probably to just about everybody in New Zealand, although the standard's been out for a while. There are a few companies, locating companies, that are using it, and there's a bit of use of the UK standard, the PAS 128 as well. But there's no consistency across New Zealand. You're not obliged to use AS5488 as a locator or even as an asset owner, but it's probably time, I guess, as the broader damage prevention community, that we start thinking about doing something along these lines. And there's no reason for us really to reinvent the wheel. It takes a lot of money to put out a standard, I can tell you. On the NULCA New Zealand website, we're hoping to add more resources that should help with those going to do their certified locator theory and also their practical. And we'll probably try and put up some more information, including a recorded version of this webinar on the AS5488. You can do an internet search. The Australian Utility magazine has some quite good articles that came out following the original AS5488 release. So I'd encourage you to do a bit of research. If you're a locator going for your certification, reach out to NULCA New Zealand. We'll try and put some stuff up there that will be helpful to those going and doing their theory exam and practical assessment. And really, that's pretty much it. It's a big subject. It's quite hard to do in half an hour. So we may run some other webinars, we may do some other things, but I guess there may be a few questions out there. So I'll see what Freddie or Andrew have actually got if anyone's asked any questions. Back to you, Andrew.